The critical scene of the mystery is when the detective enters. The action shifts to Sherlock's sitting room. The little Belgian man with the waxed mustache appears in the lobby of the Grand Hotel. The gentle old woman with a bag of knitting comes to visit her niece when the poison pen letters start going around the village. This is when things will change. Maureen Johnson, Truly Devious. I love mystery novels. And in recent years, I have fallen particularly in love with the most iconic detectives of British literature, Agatha Christie's Hercule Poirot and Jane Marple, and Sir Arthur Conan Doyle's Sherlock Holmes. I also really love giving conference talks that are a little different, a tad experimental, but hopefully memorable. And in that spirit, I present The Detective Has Arrived. Welcome to my Pi Gotham talk. I'm so excited that you're here to learn more about software security and a little bit of sleuthing. So how are we going to discuss security? Well, we're going to do it with whimsy and with mystery, and I'm really excited. So first off, let's meet our detectives, Miss Jane Marple, Hercule Poirot, and Sherlock Holmes. People don't much mind a woman in the corner knitting, but maybe they should. I, of course, have no training, no official training, but village life has given me a sort of training. I have seen both good and evil, all sorts of characters, and you get a sense of people. Sometimes they say things they ought not because they think that I am harmless. Perhaps I am, or perhaps I may be the one who is able to put all the pieces together and solve the crime. Oh, mes amis, it's so nice to meet you. So great to make your acquaintance. My name is Hercule Poirot, and I am the renowned retired Belgian detective. You shall know me because of my mustache, which is the best mustache in the whole world, tout le monde. Don't you think? Hello there, I'm Sherlock Holmes, and it is nice to see you today. Now, you may know me as the world's only consulting detective, the first and the best. Don't let the Belgian tell you otherwise. All right, so we'll have several questions for our detectives and use those questions to discuss introductory security concepts. And the first of those questions is, what do you know about your neighbors? And for a bit of perspective on that, we will turn now to Miss Marple. 15 years ago, one knew who everybody was. The Bantrys and the Big House, and the Hartnells, and the Price Ridleys, and the Weatherbys. They were people whose fathers and mothers and grandfathers and grandmothers, or whose aunts and uncles had lived there before them. If somebody new came to live here, they brought letters of introduction, or they'd been in the same regiment, or served on the same ship as someone already there. If anybody new came, really a stranger came, well, they stuck out. Everybody wondered about them, and they didn't rest till they found out. But it's not like that anymore. Every village and small country place is full of people who've just come and settled there without any ties to bring them. The big houses have been sold, and the cottages have all been converted and changed. And people just come. So what do I mean by neighbors when I'm talking about software security? Well, I mean that we need to understand the vulnerabilities in our open source dependencies. So when you start a project, you select open source libraries to use and you import them into your project, and maybe you have a good sense of what they are, maybe you don't. And maybe you do have a good sense of what they are, but you don't really have a sense of the projects they use. So this slide shows a dependency tree for my very first Python project. You can see that you have the projects that I've selected as well as projects that those libraries pulled in, right? And when you think about security, you're going to want to think about your whole neighborhood, not just your house, which is the code you wrote, but all of your neighbors and just the community in general. And because we spend a lot of time with our own code, we may think that it takes up a large portion of our neighborhood in production. But the truth is that while your pie chart of code in production may look like this, it may actually look like this or this or this. And so even if you're careful about your security, the security of the code that you wrote, there's a huge surface area of code that you didn't write. And so it's necessary to understand both the good and the bad from those libraries. So what should you know about your neighbors? Well, you should know if any packages you use have known security vulnerabilities. You should also know which packages you're using indirectly. So these are the dependencies that are brought in by your dependencies. And then you should know if those have problems. So when you go about keeping track of this, it can be really daunting. Maybe you're not sure how to get your hands around all of it. So I recommend automating when you can. And there are both open source and enterprise options that can help you do this. To summarize, you want to understand your open source dependencies and remediate known issues. Use a tool to help you do this. There are open source options and enterprise options. Are people who they say they are. Now, both Hercule Poirot and Sherlock Holmes have come across this a number of times. Miss Marple has too, but the better examples were with them. And I have the following recommendations for you all. First, if there is an actor in the story, be suspicious. Second, think about how we confirm identity. A detective might use handwriting, mannerisms, looks. Is there something more? How do you know for sure? You may also consider names, nicknames, and aliases. Are they what you expect? And is there something funny going on there? These are the things to think about when reading detective fiction. And if you would like some recommendations along these lines, I recommend Lord Edgware Dies and After the Funeral by Agatha Christie, and A Case of Identity and The Adventure of the Stockbroker's Clerk by Arthur Conan Doyle. A Murder is Announced is also good by Agatha Christie. All right. So, what should you know about authentication in Python? First, don't roll your own auth. There are people who study to do this, and it's really complicated, and there's just no reason to roll your own auth. Second, don't store your plain text passwords, not in a text file in your computer, not on a sticky note, definitely not in the database. Don't do it. Third, use two-factor authentication on your personal accounts where you can, and try to offer it in your project if it's at all possible. Now, what's interesting about this is two-factor auth can protect you, but it can also protect so many other people. For instance, the Python packaging index recently became two-factor auth compatible. What this means is that package maintainers can use two-factor auth to protect their account. But what that means is not only is the maintainer protected, but all of the people that use the package that the maintainer has are protected too. It's great. So use it wherever you can and offer it if you can. And finally, you should know about authentication is that Django doesn't throttle user authentications by default. So you should use a complementary tool to do so. And the recommendation here is something like Django Defender. Now, if we want to talk about permissions, there's a lot of interesting detective stories that could go into it. And the one that comes to mind is the case of the Speckled band. Now, the case of the Speckled band is a Sherlock Holmes story, and it has some interesting things about perimeters. Basically, there is a locked room, and a client's sister died a few years before in this locked room. And now the client is worried that she may come to the same fate. So if no one can get in the door and no one can get in the window, well, is there a problem? Well, so I suggest you read that to learn more and to find the perimeter that was not protected. All right. So what should you know about permissions? First, be as granular as practical. It's always easier and safer to grant an additional permission than to try to revoke one. And finally, think about your perimeters. So, is there a way for someone who does not have the permission to get access through like a side door, basically? Now, to sum that up, treat authentications and permissions conservatively. Don't roll your own auth, and be explicit about the perimeters in your project and apply permissions carefully. Should I trust this mysterious package? And we're going to briefly discuss injection, user uploads, deserialization, and typo squatting. So first, let's ask Sherlock Holmes. Maybe his canon has something of interest. Well, Holmes once took a case where a client received a package containing 3 severed ears. Oh. In another case, a client received 5 orange seeds, and it turned out to be this huge threat. It was one of only 2 stories in the canon where a client died after seeking Holmes's help. So no, Holmes doesn't believe that you should trust that mysterious package. So when we're handling unknowns that come to us from outside, we don't want to trust but verify. We want to verify and then trust. Assume anything that comes to you from the outside could be potentially compromising. So let's think about SQL injection. So my advice here is to write raw SQL sparingly, if at all. It's a lot safer to use an ORM like the Django ORM than to execute the raw SQL itself, especially if that raw SQL has been formatted using user inputs. That's particularly dangerous. All right, what about user uploads? If your user is uploading a picture, check that it is a picture. Confirm before you do anything with it. You don't want to think you're getting a picture, but instead get a script. If you're not careful with user uploads, it can expose you to a risk of code execution, and no one wants that. All right, what about serialized data? So if you receive serialized data and you're not sure of the source, deserializing it can expose you to risk. Again, it's a code execution thing. All right, and there's actually interesting examples of this in the Python ecosystem. There was a NumPy case where you had to explicitly say not to trust serialized data. Anyway, you can read more about it here. All right, now we turn to typo squatting. And I have a question, which is, have you ever pip installed a package without checking its name? It's really important you need to do it because people can maliciously, or they can upload a package that is malicious
to a typo of a popular package. And it could be a typo, or it could also be something where you expect a package to be named one thing, but it's named another thing. And so they squat on the name that you might expect, right? And if you don't check the package, you can expose yourself to some pretty serious malicious packages. And there was one last year in the Python package index, which it got removed and it did little damage, but it was kind of a proof of concept, if you will. And you can read more about it there. All right, so to summarize, be wary of inputs and uploads. Don't guess.
So how do we handle sensitive information? And by that, I mean, how do we treat our source code and how do we treat our user data? Now, all of our detectives have worked with sensitive information in the past, whether it's dangerous information or whether it is valuable, right? And they're very, very careful with it because they understand the danger. And in particular, if you put aside murderers for a minute, all three of our detectives have a dislike for one type of criminal in particular. Oh, Maze and me, there is no question. Blackmailers. Worst of all, blackmailers. Oh, of course, blackmailers.
They have disgust for these blackmailers because they wield personal information as weapons. That's not a good thing. All right, so protect your source code. Follow good hygiene practices, so good code hygiene, regardless of whether the repository is public or private. Don't commit sensitive information to version control. And remember that you could always have a problem from within your own house, and you should act accordingly. Additionally, you need to consider your user data. Be selective about it. Do you need to collect it? Do you need to store it? Ask yourself. You can also delegate some of this to others, whether it's delegating like transactions and stuff, or delegating the storage of this information. That's possible. And it might be a good option if you don't have the know-how in-house. Additionally, you should give your users tools to help them protect themselves. This includes things like two-factor authentication. Finally, you should view personal data like glitter. Use it sparingly, collect it sparingly, because if it gets out, it's never getting back and it's going everywhere. All right, to summarize, both source code and user data deserve careful consideration. You can't lose data that you don't collect. Git is amazing, but it's not for everything.
So Watson has told me that you have not stayed up to date on the intricacies of cigar ash.
Are you up to date on your knowledge of cigar ash? And this is about the importance of continued learning and forward progress. So security is a continual process. You are never secure. You don't reach the destination security and then you can check that off the list. New vulnerabilities are found and new exploits and attack vectors are executed, and so you gotta stay on your feet. This is true on a personal level, but it's also true on a company level and within the industry in general.
The PSF is investing in modernizing their security practices. So this is really great to see. The use of two-factor auth and API tokens on PyPI is a really good example of that, but they have a really interesting initiative going on, and I applaud them. Good job. So to summarize, security is never done. Good security is a product of continual learning and iteration. And that's the summary.
Thanks for taking this journey with me today, and thanks for being patient with my really terrible, terrible accents. I appreciate it. So just to summarize and wrap things up, remember to approach your code with skepticism. Don't be afraid to ask questions. Don't be afraid to test theories. Don't be afraid to poke at your code and see where it may be weak. Doing so will only make you stronger, and that's a good thing. And don't be afraid to ask for help when you need it. Together with the security team at your company, you can do more than you can imagine. And it's been my experience that they are more than happy to help, especially when a developer comes to them wanting to be more secure. So I'm going to leave you with a few resources that you can read up on, and hopefully they will help you continue in your secure coding journey. The links are here, but I will post these slides on my Twitter and you can access them super easy. So again, my name's Hayley Denbraver. I'm a Python enthusiast. I have a bit of a security background. I'm an experienced developer advocate. I'm looking for my next role. If you've enjoyed my work, please consider passing my info along to your friends who may be hiring. I'm based in Seattle and open to remote. You can find me on Twitter at HayleyDenB, or you can email me directly, hayley.denbraver@gmail.com. Thank you all for listening and for your attention. And thanks especially to PyGotham and their interesting pivot into this digital version of PyGotham this year. I think the theme was really great, and I really appreciate the organizers and the attendees too. Thank you for watching. I hope someday in the future we can meet again in New York City. Thanks. Bye.
I don't know if it'll come off very well. Ooh. Yikes. Ow.